to deal with omitted variable bias, we can add more x variables into our regression equation. So that would give us the multiple regression model, the MRM. As previously, when we have a regression model, we have a population regression line. And since we have multiple x variables, the population regression line is given by y plus the intercept, still the intercept, and times the slopes times every single variable. And notice that in this case we have k right hand side variables, okay? and you can actually have as many as you would like, but if you have more right hand side variables than you have data, then you might end up in trouble. So how do we interpret the slope on the first variable, the x1 variable in this case? As previously, it's actually the effect of 1 unit change in x1. But in this case, we also hold the other x variables constant, which means that we only vary x1 by 1 unit, and then we read off the associated change in or level in the y variable. So for example, k equals 3, which means that we have 3 right hand side variables, 3 x's, and which means that we have this population regression line, y equals the intercept times the slope of x on x1 times x1 plus the slope of x2 times x2 variable plus the slope on the third variable times x3 plus the residual. So what if we change x1 to x1 plus 1, right? But we hold everything else fixed. x2 and x3 are fixed. Before the change, we have the ordinary population regression line here, here, and after the change, we have to insert the x1 plus 1 because we're changing x1 by 1 unit, which gives us the new value of or new expected value of or new value of the y variable, which is the slope times beta 1, right? Because beta 1 is just 1 times beta 1 plus the x1 times beta 1 and so on. So if we take regression 2 minus regression 1, 2 minus 1 equals the beta 1 population slope. So this is the difference between these two regression values. So how do we interpret the intercept in the population regression equation? It's just as in the simple regression model. Whenever the x variables are set to 0, then you are left with a y variable which contains of the intercept, right? So it's the expected value of of the y variable when all the x variables are 0. And as previously, we can estimate the population regression by taking a sample, a random sample, and applying the ordinary least squares method. So the sample regression line would be the expectation of y would be the intercept times the slopes times the x variables, the value of the x variables. And the sample residual is just the observed value of y minus the fitted value as previously. Just now you're fitting the y value by looking at more than one dimension. So just as previously, we fit this line by minimizing the sum of squared residuals. Okay, so which is the yi minus the beta hat 0 plus beta hat 1 x1 I plus up to our k x variables, and you just sum over all n observations. Okay, so and this, you, let's see where we have it, you minimize by changing all the betas. Okay, so this was a short intro to multiple regression. See you next time.